Hey there, class. Mr. Pohusky here. Hope you're having a good day so far. Today we're doing 2.8, which is absolute value functions is the name of the lesson. Our essential questions are be able to identify the parent graph of an absolute value function, be able to graph an absolute value function identifying a, h, and k, be able to write the equation of an absolute value function given the graph. All right, so a parent graph, which is this, y equals absolute value of x is going to be the parent graph. So what does that mean? A parent graph is something like y equals x squared, for example, is a parabola, right? Whereas if we do y equals x squared minus 4, that's going to be a parabola shifted down 4, right? So a parent graph's like the original basic function, also like y equals x to the third, a cubic, would also be a parent graph, and also y equals absolute value of x like this, okay? So we are going to, I'm not sure what this graph really looks like, so we're going to go ahead and, I mean I do, but we're just going to pretend that I don't so we get the gist of how to figure out what these are going to look like. So let's plug in some numbers here. We got negative 2, negative 1, 0, 1, and 2. Save some room in this area down here to write some stuff. Just keep some room down there. Don't fill that space in yet. Okay, because we're going to fill in stuff over there quickly here, okay? So we're going to plug in these values in for x. Y equals absolute value of negative 2. Let's do that one first. Well, absolute value is asking how far from 0 is the number in the brackets. So how far from 0 is negative 2? It's going to be 2. All right. Same thing over here. Y equals absolute value of negative 1. How far is negative 1 from 0? That's going to be 1. Keep going. Y equals absolute value of 0. That's an easy one. That's going to be 0. And then if you look here, you might see a pattern. Y equals absolute value of 1. How far is 1 from 0? It's also 1. You see a pattern here? We got 0 in the middle. We got 1. So let's do the same thing here. Let's do y equals absolute value of negative 2, or positive 2, that is. That's going to be positive 2. So what does this look like? Let's graph this. All right. So I'm going to start with 0, 0. We got 0, 0 right in the middle here. I got negative 1, 1, so I go left 1, up 1. I got 1, 1, so I'm going to go right 1, up 1. Then I got negative 2, 2, so left 2, up 2. And I got 2, 2, so I'm going to go right 2, up 2. And here is our graph's going to look like. Kind of like a V. It's not perfect, but it'll work here, okay? So that's an absolute value function. It's almost like a linear function like y equals x or y equals negative x, except it's going to reflect, it's going to be all positive values. It's going to be all positive values. Okay? So where's the vertex? The vertex is like, the middle point where the axis of symmetry would be. So if we drew a line straight down the middle here, it would be a symmetrical function, right? It would be, these are the same distance away from either side, basically. Okay, so the vertex is where the symmetry, where the right down the middle, where it folds in half, it'll be perfectly symmetrical on both sides. That's going to be 0, 0 for our parent function. All right, and which way does this graph open? Is it open up or open down? The original parent function is going to be open up. It's the V is facing upwards. All right, so a couple things to keep in mind here. Let's go ahead and make some room. So first thing, go zoom in a little bit here. So the original, the general form of a absolute value function, the general equation we're going to use is y equals a, that's the absolute value, x minus h, close absolute value, plus k. All right? This is general form of an absolute value function or equation. Okay, the second thing we need to know is the vertex is going to be h comma k. H comma k. So remember, it's always x minus h right here. So you got to be careful. It's x minus h. So if this is a negative, this means h is actually positive. If this is a positive right here, h is actually going to be a negative. All right. Number 3. If a is greater than 0, it's going to open up. If a is less than 0, it's going to open down. Well, what does that mean? If a is greater than 0, what numbers are greater than 0? Positive or negative? Positive numbers. So if a is positive, it's going to open up. And if a is less than 0, which means it's going to be a negative number, it's going to open down. So automatically, if you see a -2 right here, it's going to be like, oh, it's negative, it's going to be open down. If you see a 5 right here, oh, it's positive, it's going to open up. All right, a couple more things. The graph is wider if the absolute value of A is less than 1. So if A is a fraction that's less than 1, it's going to be a wider V on the graph. And conversely, if we have the graph is going to be narrower if absolute value of A is greater than 1. Okay, so if it's 2 or bigger, actually 1.01 or whatever, anything bigger than 1, it's going to be a narrower graph. So if we had something like 3/4, that would be a wider graph because it's less than 1. If we had something like even -7, that's going to be a narrower graph because the absolute value of that is bigger than 1. Okay? All right, kind of complex, kind of, I don't know, what's the word? Theoretical, I guess. So let's go ahead and get into some actual problems here and see how we do. All right, so we have y equals the absolute value of x minus 3, and that is it. So I'm going to rewrite this. Remember, the formula is y equals a x minus h plus k. So what's our a value here? There's nothing in front of the x minus 3 absolute values. What number is automatically going to be there? Well, that's going to be a 1. We can imagine there's a 1 there. And do we have a k here or no? We don't, so I'm going to add a 0. That's going to kind of help us fill in those spots here, okay? All right. So first thing we want to find is the vertex. Remember, it's h and k is the vertex. So what's the vertex for, what is h going to be? Well, it's x minus h and it's x minus 3. So h and 3 are going to be the same. So that means that the vertex is going to be 3. And then what's our k value? Well, these are going to be their k value, which is going to be 0. Okay? When you're graphing these, you can pick, I picked 5 points right here at the top to figure out the general shape of the graph, but you only need 3 points basically to do this, okay? So I'm going to put 3 and 0 in the middle, and I need numbers that are to the left and to the right of 3 on the number line. What number is to the left of 3? We're going to have 2. And what number is to the right of 3? We're going to have 4. Okay? Does this graph open up or open down? We'll come back to that in a second. Actually, we'll fill in the graph here. Let's fill in the table that is. Okay, so we're going to plug in 2. So we got y equals absolute value of 2 minus 3 equals 2 minus 3 is -1, right? And then absolute value of negative 1 equals 1, so we're going to get 1 for both of these. Okay, once you find 1, since it's symmetrical like a parabola, it means it's going to be the same for going sides of y there. You have to make sure you pick the right value on either side of the vertex, though, okay? All right, now, does this graph going to open up or open down? Is A positive or negative? It's positive, so it's going to open up. All right? Is the width compared to the parent graph going to be the same? Is it going to be wider or narrower? Well, A equals 1. A did not change, so that means that we're going to have it be the same, or normal, I guess. All right. Cool. There's an example. Cool. All right, next one, number 2. We have y equals -2 times the absolute value of x, all plus 5. So remember, it's y equals a, that's the absolute value of x minus h, all plus k. All right. So, what is our h and our k for this one? I don't see anything inside the parentheses besides x. So what's our h going to be? It's x minus what? Minus 0. X minus 0. And what's our k? It's going to be 5. So we have 0 and 5 is going to be our value for the vertex. Does it open up or open down? Well, it's -2, so it's negative, so it's going to open down. And is -2, is that bigger than 1? The absolute value of that bigger than 1 or less than 1? So it needs to be this needs to be absolute value of 2 needs to be bigger than 1, or it needs to be like 1/2 or 1/4 or something like that. This is actually, the absolute value of -2 is actually, it's bigger than 1, so this is going to be a narrower width, basically. And why does that happen? Well, if you plug in the same values here, say you plug in, it was y equals 2 times the absolute value of x. So if we do that, let's just take a look here. Y equals 2 times the absolute value of 1. Oops. That's going to equal 2. We do y equals 2 times the absolute value of 2. That's going to equal 4. So for the same graph, we're going to have 0, 0. We're going to have 1, 2. We're going to have 2, 4. 1, 2, 3. Oh, went too high. 2, 4. Or else we got the same thing over here. So you can see why, if we do that, it's going to still make it. It's going to make it skinnier because it's going to make it more negative or more positive more quickly. Okay. All right. So back to this. So we got it's going to be narrower, and we're going to check it. Numbers to the left of 0 and to the right of 0 are negative 1 and 1. Let's plug in 1 because that one's a little bit easier. So y equals negative 2 times the absolute value of 1 plus 5. Negative 2 times the absolute value of 1. Absolute value of 1 is 1. 1 is 1 away from 0. We've got negative 2 plus 5, which equals 3. So these should both be 3 if you plug them in correctly. Okay. I want you guys to give the last one a try on your own, see how you do, and then we'll go over this in a second. All right, so let's do it. So we have y equals 1/2 times the quantity in the absolute value of x plus 1, all minus 4. What's the vertex? We need x minus h plus k. So it's plus 1, so that means h is negative, which means it's going to be negative 1. And our k is going to be negative 4. Does this open up or open down? Is 1/2 bigger than 1 or less than 1? Or positive or negative, that is? It's going to be positive, so it's going to open up. And is it going to be wider or narrower? Well, 1/2 is less than 1, okay? So it's less than 1 or bigger than 1, whereas absolute value, or open up or open down, is less than 0 or greater than 0. So so A is less than 1, so this is going to be a wider width. All right? So let's plug in our values here for our vertex. We have negative 1 and negative 4. So numbers to the left and right of x are negative 2 and 0. I'm going to plug in 0 because 0 is an easier one to plug in. So to make your life easier, don't work harder. So we're going to do 0 plus 1 all minus 4. Y equals 1/2 times 0 plus 1 is 1 minus 4, which equals 1/2 times 1 minus 4. So we got 1/2 minus 4, which equals negative 3.5. That was really sloppy. Okay, so you're just going to plug in those values and then simplify. And then once you get one side, it's going to be the same on the other side. But you got to be careful that you pick the right numbers. It's got to be symmetrical. Okay, it's got to be symmetrical right here. All right. Okay, there we go. Moving on to the next page. Got a lot more to cover here. All right. General form of an absolute value function. And remember, like I said, it's going to be y equals a times x minus h, absolute value of that, plus k. Couple things. A is going to be greater than 0, means it's going to open up. And a is less than 0 means we're going to open down. Okay. The shape of the graph is V-shaped. Okay. And the width of the graph compared to parent graph, if the absolute value of A is less than 1, that's going to equal, it's wider than PG, parent graph. And absolute value of A is greater than 1, that's going to equal, narrower than PG. And the vertex of this is going to be H comma K. All right, it's going to be a longer video today. I apologize for that, but I want to make sure we go through this all at once here. So yeah, here we go. It's for each of the following, identify the vertex, the direction of opening, the width, and the graph of the function. All right, let's do it. So we have y equals the absolute value of x minus 3, all plus 1. What's our a? What number's in front of the absolute value? We have a 1. What's our h? Remember, it's x minus h plus k. So h is going to be 3, and k is going to be 1. Okay? So our vertex is going to be h and k, which is 3, 1. 3 and 1. Direction of opening, is it going to be open up or open down? Is a positive? A is a 1 in front of here. Is that going to be positive or negative? It's positive, so it's going to open up. And the width is a absolute value of 1. Is that equals 1, right? So it's not going to be, the width is actually going to stay the same. All right, the width's going to stay the same because it's not bigger than 1 or less than 1. So it's going to stay where it is. It's equal to the parent graph, basically. Okay. What numbers are to the left and right of 3? Well, it goes 2, 3, and then 4. Okay, so let's plug in 2 now. So let's do y equals absolute value of 2 minus 3 plus 1, which equals absolute value of negative 1 plus 1, which equals 1 plus 1, which is 2. So both of these are going to be 2. All right, let's graph it. So we got 3, 1, so we're going to go right 3 up 1. We got 2, 2, we're going to go right 2 up 2. We got 4, 2, we're going to go right 4 up 2. And there's our graph. There's our V. Basically, it's just the parent graph. It's been shifted over to the right 3 and up 1. Okay. All right, number 2. Y equals negative 3 times absolute value of x, all plus 2. What's our a value? It's going to be negative 3. Why don't you guys give this one a try on your own and see how you do compared to the last problem. Go ahead and give it a try. All right, welcome back. What's our h and our k? There's no other number inside by x, so this is going to be h of 0 and k of 2. So our vertex is going to be 0, 2. Is it going to be open up or open down? Is negative 3 bigger than 1 or less than, or bigger than 0 or less than 0? Well, it's negative, so I guess I could just say positive or negative. It's negative, so it's going to be open down. And the width is negative 3. Is the absolute value of negative 3, is that bigger than 1 or less than 1? It's bigger than 1, so it's going to be a narrower width. What numbers are to the left and right of 0? We have negative 1 and 1. So let's plug in y equals negative 3, absolute value of 1. You can test any number you want, but I like to pick the easier number to plug in. Negative 3 times 1 plus 2. Negative 3 plus 2, which equals negative 1. So it's going to be negative 1 and negative 1, and 1 and negative 1. It's going to mirror. Like over here, straight down the middle. The mirror image on either side. That was a really fat line there, but you get the idea. Straight down the middle here is going to be a mirror image on either side. Okay, so once you get one of these, you're going to get the second one easily because you know that they're going to be mirror images. Okay, so 0, 2, we're going to go up 2. And then our other points are left 1, down 1, and right 1, down 1. You can see that we had that negative 3. It made it more steeper or narrower of a V. And there's going to be our graph. All right, 2 more examples, and then we're done for the day. Write the equation of the graph, determine the value of a, and find the vertex to help you start. All right, we're looking for a, so we need to find the vertex, which is the pointy part of the graph. It's like the tip of the V, either top or bottom. So what is our vertex for this? What's the coordinates of that? It's going to be 2, 1. Okay. So now what we need to do, so we know the equation is going to look something like this. It's going to be y equals a, absolute value of x minus h, all plus k. Right? But we need to solve for the value of a. We don't know what that is. So what I'm going to do is I know my h and k equals 2, 1. I'm going to pick an x and a y. Just pick another point on the graph that's going to represent the, we're going to solve for h, or solve for a using that information. So what point do you want to use? We're going to use this one or this one. I'm going to use the 0, 3. I think that's an easier one to plug in. So we're going to use 0, 3. So now we're going to take all of these, we're going to plug them in for x, y, h, and k, and then we're going to solve for a. It's going to be a nice little shortcut here. So we have y equals 3 equals a. X was 0 minus h, which is 2, all plus k. Oh, wait, k was actually 1, sorry. Okay, so what we're doing, we're trying to figure out the equation of the graph just by looking, or the equation of the graph by just looking at the graph. And so we need to take some information and use algebra to figure this out. Okay? So let's solve this now. So we have 3 equals. We need to do absolute value first. It's like grouping symbols. It's like parentheses. So 0 minus 2 is negative 2, all plus 1. We have a times, well, actually, what is the absolute value of negative 2 going to be? That's going to be 2. So now we have 2 times a plus 1. You could write a times 2 if you wanted to, but 2a is how we usually write that. How do I solve for a now? We got an equation here. We're going to subtract 1. 2 equals 2a. Now what do? Divide by 2. 1 equals a. So our answer is going to be, a is going to be equal to 1. And now that we have our h and k, it's going to be y equals 1 or nothing. We don't need the 1 there. X minus our h, which is 2, plus k, which is 1. And that's going to be the equation of that graph. Okay, so we took information that we knew, we picked another point on the graph, and then we solved by plugging stuff in and using the vertex and another point and solving for a. Try number 2 on your own, and the points you're going to use are this one, and then these are both points right here. It's kind of a sloppy graph. It got kind of shifted when it got transferred over, so those are the points you're going to use. So go ahead and give this one a try, see how you do. All right, the vertex is the pointy part of the v's. What's the coordinates of the vertex? It's going to be negative 1, comma 4. All right, we need to find an equation, so we're going to use our h and k equals negative 1 and 4. We need to find another point we want to use for x and y, which is going to be, I used 0 and 2. Use whatever point you want, though. So we're going to do y equals a times the absolute value of x minus h, all plus k. So we're going to plug stuff in, so y is 2 equals a, absolute value of x, which is 0, minus negative 1 is going to be plus 1. I'm doing a shortcut here. Minus negative 1, which is h, is going to be plus 1, plus k, which is 4. All right. Now we have 2 equals a times absolute value of 0 plus 1. Remember, absolute values are like grouping symbols. They're like parentheses. You got to do those first. 0 plus 1 is going to be 1 plus 4. The absolute value of 1 is 1, so it's just going to be 2 equals a times 1, which is just a, plus 4. And the last step to solve for this is to subtract 4 from both sides. And we're going to get negative 2 equals a. Actually, I'm going to write a equals negative 2. A equals negative 2. So that's our value is negative 2. So our new equation is going to be y equals negative 2, absolute value of x, minus negative 1 is plus 1. Remember, it's always minus h, but if h is negative, it's going to be plus, and then plus our k, which is 4. All right, and then there is our equation taken from a graph. All right, thank you for watching. I know it's a long video, but I appreciate you guys sticking with it. And take care, have a good night. We will see you soon.